Welcome to the Teachers E-Symposium 2020, organized by Oxford University Press, Pakistan. The title of the session is Inquiry-Based Science Classrooms, and I am your facilitator, Tooba Malik. Before we begin, let me introduce myself. I am currently working as an academic coordinator at Oxford University Press, Pakistan. I have a degree in business administration with a bachelor's in science. I have been associated with the field of education for the past 15 years. I have a challenge for you called Walking on Eggs Challenge. I will show you a video and then I would like you to write down your reflections in the chat box. All right, you have a minute to write down the secret behind walking on eggs. Please write down your responses in the chat box. All right, we have a response. Yes, the shape of the egg does contribute to walking on eggs. Yes, the equal pressure applied by the woman. That's also correct. All right, thank you so much for your responses. So what's the secret? The shape of the egg. It is similar to a three-dimensional arch, which is one of the strongest architectural shapes. The shape of the arch distributes forces, thus making it a very strong structure. The shape gives it tremendous strength. The curved shape helps to distribute pressure evenly. If we apply uneven force, the eggs will break. And you might have noticed that the lady was applying an even force so that the eggs don't break. And let's not forget that there was an egg carton underneath the eggs, acting as a cushion. So that's the secret behind walking on eggs. Let's take a look at the session outcomes. The first thing that we're going to talk about is what is science made up of. Then we will take a look at the key principles and the inquiry-based learning cycle. Then I have a few tips for online teaching, and then we'll take a look at some websites for science learning. So what is science made up of? Science is made up of facts, knowledge, and understanding. Let's take a look at this example from physics, where we tell the students about what a force is, then we discuss different types of forces contributing to their knowledge about it, and then the centripetal forces in space. If the student understands this means that they understand the practical implication of the concept taught to them in class. Let's take a look at this example from chemistry, where we tell the students We give them factual knowledge about the particle theory of matter, and then we tell them about the processes like evaporation, boiling, condensation. And then, if they understand the altitude effects on boiling points, or they experiment to find out about them, that's where we say that they have developed an understanding of the concept taught to them in class. Let's take a look at this example from biology where we tell the students about the human skeleton. We discuss different components. We tell them about the muscles, movements, and the organ systems. And if they understand the organ transplants and how the organ transplants help human beings and what makes them possible, that's where their understanding comes into play. So, what is the role of students in inquiry-based learning? Students are responsible for becoming experts through a process of self-discovery and trial and error. They build their own initiative and they're motivated to make their own connections about what they learn. So they basically lead the inquiry in the class or outside of the class. Whereas the teachers, they monitor the process of knowledge construction and they intervene only when students need help. So teachers basically monitor or facilitate the process of learning that has been initiated by the students in the inquiry-based learning cycle. All right, let's take a look at the key principles behind inquiry-based learning. We say that students are researchers in this process, the teachers are research assistants, there's peer-to-peer collaboration happening, and then there's reflection on learning. Students as researchers develop their own research questions. They look at the question from multiple perspectives, and these could be with the help of their peers or the teacher helping them out to look at different angles of the concept or the question that they've asked. And then they revisit the question each time new information is learned. So what students do is they elaborate and they refine their answers and they gradually become experts on the topic. This is an example from Complete Biology for Cambridge Secondary 1, where students as researchers ask a question like, what are trees made of? And then they suggest explanation that they are made from nutrients which they take in from the soil. And then they test this explanation by careful measurements and they experiment. And they ask further whether the tree takes anything from the soil as it grows. And then they check the evidence whether it supports the explanation. If it does, and the answer is yes, the explanation is accepted. Otherwise, if it's a no and the evidence does not support the explanation, they go back and they come up with a different explanation. This is an example from Complete Physics for Cambridge Secondary 1. The students are studying about streamlining in this chapter, and they might wonder what factors affect how fast things can move through water. Now, in order to conduct this investigation, they need to come up with a specific question so that they can gather evidence to support their explanation. Now, the specific question could be, how does the shape of an object affect how long it takes to fall through water? They need to come up with a specific question to conduct their investigation. The role of the teacher and student in inquiry-based learning is flipped. The instructional lessons are delivered online, and class time is devoted to students applying what they've learned through practice and collaborative tasks. This is an example from Complete Chemistry for Cambridge Secondary 1, where the students have been told that Laura measured the boiling point of pure water and salty water, and she found out that the boiling temperature of salty water is higher than the boiling temperature of pure water. The students have been asked to write down a question that Laura could investigate, also suggest an explanation based on the evidence that she has already collected, and then they have to suggest how Laura could test this explanation. The third principle is peer-to-peer collaboration. The students become each other's soundboards while collaborating with each other. Group projects such as debates, group presentations, newsletters, and discussions provide further insight into the topic. This is an example from Complete Physics for Cambridge Secondary 1, where a student is investigating how the shape of an object affects how long it takes to fall through water. Now, she's recorded her results in a table, but she's asked one of her peers to help her out with the time of the fall to get accurate results. And that's where peer-to-peer collaboration comes into play. Reflecting on learning helps students identify areas for improvement. So they can ask questions like, what can you do to improve your learning? What can your teacher do? And teachers can also encourage reflection through assessment feedback. It guides teachers in modifying their future instruction. This is an example from Complete Biology for Cambridge Secondary 1, where the students learn that after developing a scientific explanation for their work, they can uh, consult other students and look at their work and then build on each other's work. So if, for example, one student establishes that leaves can only make nutrients if they have light, and another student talks about the plants needing small amounts of minerals which they absorb from the soil through their roots, then they still ask questions about how plants make nutrients, and then they can ask more questions to understand how the importance of plants in our everyday life, and also how we can grow those plants that we need for our survival. Here you can see the inquiry-based learning cycle, which comprises of 5 stages. The first one being ask, where students develop critical thinking skills right from the start of the cycle. With the teacher support, they establish the central theme or topic that they want to study, and then they use their own ideas to drive the learning process. In the second stage, investigate, the students identify key questions. They draw on their own knowledge or experience to support their inquiry. Then the third stage is create, where they use examples or engage in creative hands-on activities that require them to actively collaborate with their peers and use other means to deepen their understanding of the topic. The fourth stage is discuss, where students take responsibility for their learning and they engage in analyzing what they have learned, and then they draw conclusions and present their recording using the appropriate tools. The last stage in the cycle is reflect, where the students reflect on or check their understanding and test their initial hypothesis. During the first stage of the inquiry-based learning cycle ask, you can show a short video clip on the topic. You can create a digital mind map using websites like MindMeister. These can be used to brainstorm and then establish the central theme or topic the students want to investigate. Or you can also use a KWL chart. This is a KWL chart, and let's take a look at this example from the topic, the particle theory of matter. Now, during the ask stage, we fill in the first 2 columns, and the first one is what I know. So, say for example, I say matter is made up of atoms, particles, and what I want to know, how do substances change shape? Now, the first column here activates prior knowledge of the students, and the second one allows them to share unit objectives. And we fill the first 2 columns of the KWL chart during the first stage of the inquiry-based learning cycle, which is ask. These are some questions that you can use to engage the students during the first stage of the inquiry-based learning cycle. So you can ask them questions like, what do you know about antibiotics? What do you not yet know about carnivores? Or what would you like to learn about natural habitats? Why do you think the blade of a cutter does not scratch glass? These questions will spark their curiosity, and they will set about developing the central theme or topic they want to investigate. During the investigate stage of the inquiry-based learning cycle, students can conduct laboratory investigations. They can go through online simulations to understand the concept better, and they can experiment as well. They can create models to deepen their understanding of the topic or to explore it more. They can read articles to expand their knowledge about the topic or the central theme. Some questions to help students investigate. Why do you think heart muscle cells have a lot of mitochondria? Does the shape of an ice cube affect how slowly it melts? Or in what ways is your ear like a microphone? During the investigate stage, students can go through online simulations by using forums like PhET interactive simulations. Given in front of you is the URL link to PhET interactive simulations, and the topic is states of matter. Right below it is a screenshot from the website where the students can observe the behavior of atoms and molecules in response to an increase or decrease in temperature. They can also see the solid, liquid, and gaseous state of water molecules. And they have the choice of actually choosing between substances. The choice given on this page is between neon atoms, argon atoms, oxygen molecules, and water molecules. And they can observe the behavior of these by increasing or decreasing the temperature. This is another screenshot from the same website, PhET Interactive Simulations. Here, the students can observe phase changes, and the students have the option of increasing or decreasing the pressure as well. And they can take a look at the interaction potential. They can also look at the phase changes of these substances with changes in the temperature and pressure. These kind of online simulations benefit the students in terms of their learning. During the create stage of the inquiry-based learning cycle, students explain their observations, they present their concept or concepts through appropriate tools, they read the text, or they can also complete the KWL chart. During the create stage, the students complete the KWL chart. So they filled in the first two columns, and now in the topic, the particle theory of matter, they write down what they've learned. So for example, they write down substances expand on heating and contract on cooling. This allows students to monitor their own learning. Here are some questions to help students create. Suggest why it is important to use scientific knowledge when writing a conclusion to an investigation. A student thinks that the outer planets have longer years than the inner planets. Do you agree? Explain your answer. Explain why phytoplankton grow faster in coastal waters than they do in the middle of the ocean. Some things that the students can do during the discuss stage of the inquiry-based learning cycle is that they can conduct a research, they can compare and analyze data, they can conduct an experimental investigation, they can also solve real-world problems during this stage. Some questions to help students discuss. Explain why most of the medicines used to treat malaria no longer work. There is a limit to the length of straw that you can use to suck the liquid up. It is almost impossible to drink through a straw that is more than 3 meters long. Why? Suggest why Fatima does not investigate the question, which fuel is best? Students can, during the reflect stage of the inquiry-based learning cycle, develop brochures, articles, advertisements, etc. They can construct a model. They can solve worksheets, quizzes, unit tests. They can present information by choosing the appropriate graphic organizer. Some questions to help students reflect. The student wonders whether the results would be similar if they used a different acid to test reaction rate. Suggest how they could investigate. Explain why vitamin D deficiency is more common in countries away from the equator. It is almost impossible to balance a pencil on its point. Why? Here are a few tips to use while conducting online classes. First of all, choose the right platform to communicate with your students. Think about what best fits the need of your students. Then, if there are any additional technology needs, like you need a headset to minimize distractions, or you need to use the camera, do a test run before the actual class, a good internet connection is a must. Also, managing online teaching lesson dynamics. So keep away from distractions. Make sure that the place that you're sitting in is well lit and the students don't get the chance to look at a lot of background images and not focus on you while you're teaching. So make sure that there is minimal distraction for the students. Then include online activities, and for these activities you can use forums like Padlet, and this is a wonderful tool that you can use to get feedback from the students, and also provide, and you can also provide them with feedback using the same tool. Also, in online teaching, it is a must, I would say, to provide clear instructions to the students, because you're not with them and you're not there to observe their body language. So keep things simple and provide clarity in whatever you say to them, and whatever expectations you have, they should be very clear with the students. I've shared with you some online resources for science learning, and the first one out of them is PhET, Interactive Simulations. PhET stands for Physics Education Technology, and let me assure you that it is not just for physics students. It is an extensive education research program or forum that engages students through intuitive game-like environment where students explore and discover the concepts they are learning. There are around 100 plus interactive simulations from subjects like physics, chemistry, biology, earth sciences, and maths. It helps the students visually comprehend concepts. And like I just showed you a little while ago, these kind of simulations, online simulations, really benefit the students in all respects. Then we've got National Geographic Education, where the students can explore their curiosity through various challenges and explorer classrooms. There are many educational resources and activities like maps, lesson plans, imagery, interactives, and reference materials in a very novel approach that National Geographic takes around science, exploration, and storytelling. So it piques the students' interest, it keeps them engaged. It also offers professional learning opportunities to educators. Then there is Nearpod. Nearpod is a forum where you can engage your students, whether you are conducting online classes or you are conducting face-to-face lessons. It doesn't matter. You can use Nearpod. And it offers both the teacher-directed learning for the whole class or can be used independently at the student's own pace. So you have the option of choosing between the two. Lessons can include videos, web pages, PDFs, drawing pages, images, polls, multiple choice questions, open-ended questions, etc. Students can actively participate in the lesson while teachers get valuable feedback on student learning. I've used this forum to conduct teacher training sessions where teachers had to just click on the link in their browser that I sent them, and then they had the option of actually giving me feedback or writing to me, and the result would be and the result could be displayed and seen by everyone. The OUP resources for lower secondary science consist of the student books, workbooks, and teacher packs. I've already shared examples from the books and the workbooks to show you how students are encouraged to explore, ask questions, and share ideas. The teacher packs include lesson ideas and teaching resources to save time. There are challenges and additional exercise worksheets in the teacher packs to stretch students' ability. These books support the Cambridge Secondary 1 Science Curriculum Framework, and it also prepares students for the Cambridge IGCSE. I would like to wrap up this session by talking about some of the benefits of inquiry-based learning. It encourages a deeper understanding of concepts. So inquiry-based learning is designed to teach students a love of learning. Students are able to engage with the material in their own way, and not only are they able to gain a deeper understanding, but they're able to develop a passion for exploration and learning. Students form their own connections about what they learn. So during this process, students understand why the rule or formula works, or how the idea was developed, and when can they apply the rule, formula, or idea. Also, the use of open questions in the inquiry-based learning cycle promotes students to utilize their own methods and thinking styles to solve problems. So they put themselves at the center or heart of the experience. Students develop critical thinking and life skills necessary to be competitive in the 21st century, from problem solving to effective collaboration and communication. So, life skills like leadership. So, students display leadership skills when they take the initiative and lead the inquiry. They learn how to be more productive when they plan, research, analyze, evaluate, and apply their learning. Their social skills are enhanced when they communicate and collaborate with their peers, with other people in their group projects or tasks. Please visit the OUP-ELT-Global-Blog.com website to learn more about inquiry-based learning, the key principles behind it, and the cycle. Also visit the global.oup.com website to learn more about the resources that are available for complete science for Cambridge Lower Secondary 1. Also listed here are a few other websites like VET Interactive Simulations, stevespanglerscience.com, nearpod.com, and nationalgeographic.com that are worth exploring.